All right, from some point of view, these are the same question, but we'll do both of them. If tangent of theta is equal to negative 8/7, okay, so that's one piece of information. This tangent being equal, tangent of some angle is equal to negative 8/7. So I'm going to write that over on the iPad. You can't see it, but tangent of theta is equal to negative 8/7. Then they give you a second piece of information that says that sine of that same angle is greater than 0. So two pieces of information. Sine of that same angle is greater than 0. And when I say the sine of that angle is greater than 0, hopefully you understand that they're saying the sine of the angle is positive. Okay, the sine of the angle is positive. That's what it means to be greater than 0. If it was less than 0, then it would be negative. Okay. Over here in this problem, they give you the same type of information. They tell you the sine of some angle is negative 2/7, and then they give you a second piece of information that says that the angle is in quadrant 3. Okay, so we'll focus on the first one, most of which is going to happen over here on the iPad. If I know that the tangent of the angle is negative 8/7, I can look at that a couple of different ways. I believe the easiest way is to think about all the different ways that tangent is, the only word that comes to mind is realized. So we can think of the tangent of some angle as equal to the y over the x. We can also think of it as the length of the opposite leg divided by the length of the adjacent leg. This is kind of the one that we want to think about now. Since the sine of the angle is greater than 0, meaning that the sine of the angle is positive, that should inform us that the terminal side of my angle is in either the first quadrant or it's in the second quadrant. We don't know just yet. Okay? And of course, the initial side of the angle is always on the positive x-axis, so it's over there. So either we have this orange angle or we have this green angle. One of the two. Now, they tell us that the tangent of that same angle is negative 8/7. So I'm going to draw my little triangle. First, I'm going to get rid of some stuff. These two arrowheads, because they're clunking it up. I'm going to draw my little reference triangle, as I call it. And I'm going to label these two side lengths. I'm going to label the length of the opposite leg as 8, and the length of the adjacent leg is 7. But notice that this one is positive because it's in the positive y direction. This one is also positive because it's in the positive x direction. So how can we get a negative 8/7? Well, we can't. This really means that the angle that we're talking about is the green one over there in the second quadrant. And so that second piece of information is trying to help us distinguish between two different possible angles that could have tangent of that angle equal to negative 8/7. By the way, the other angle that could have negative 8/7 as its tangent would be in the in the fourth quadrant. Because in the third quadrant, both x and y are negative. In the fourth quadrant, over here, x is positive and y is negative. So this we could have negative 8/7. But they told us that sine is positive, so it cannot be down here. Hopefully that's clear or understood, or understandable the way I explained it. Now that we know that our angle is in the second quadrant, we can draw our triangle. Do that. Label this as 8. Label this as 7. Those are the lengths of those sides. And of course, this negative sign is going to be attributed to the 7 because that's the negative x direction. It cannot be attributed to the 8 because the 8 is in the positive y direction. Now that we have those dimensions, I can find the length of the hypotenuse. How? Pythagorean theorem. So the length of the hypotenuse is equal to the length of the sum of the squares of the lengths of the legs. If we want, we could label them as xy as well. Same difference. We could label any letters we want, stickman if we want. So negative 7 squared plus 8 squared. The negative sign is not going to matter because negative times negative is positive, so I get 49 plus 64. And so I get h squared equals, what is that, 113? And so I get h is equal to square root of 113. So my hypotenuse or as a former student called it, the hypotenuse, has the square root, has a length of the square root, oh, come on, poop face, has the length of the square root of 113. Okay, so now, over here on the left, in orange, we're going to list these requests from the problem. What is the sine of the angle? What is the cosine of the angle? What is the tangent of the angle? What is the cosecant of the angle? They put secant first, so be careful. I always write them in order of the reciprocals and just do it that way, but be careful. Note they have secant instead of, their order is different, so you can't just type them straight in and get them correct. Okay? Sine is opposite. Here's our angle, right? Here is our angle, theta. And here's our reference angle, alpha. And so our opposite leg is 8. And our hypotenuse is the square root of 113. You could rationalize the radical, but I'm almost 100% confident, that my open math does not care about rationalizing radicals. You could enter 8 divided by the square root of 113 in many problems. This one, because of the way the guy wrote it, painful if you ask me, but he wants you to round your answers to 1 decimal place. And that's just weird. So we'll get a calculator out and get numbers for these. Cosine is going to be the adjacent leg, -7, divided by the hypotenuse. And tangent is going to be this -8/7, because that's what's given to us. We don't have to do any arithmetic there or any thinking there. Cosecant is going to be the reciprocal of sine, so that's square root 113 over 8. Secant is the reciprocal of cosine, so that's going to be square root 113 over -7, or you could say -7 square root 113 over 7, or whatever. Cotangent is going to be -7/8 because it's a reciprocal of tangent. All right, so now we're going to jam this into the calculator. I'm going to go 8 divided by square root 113. And I get 0.75. 1 decimal place is 0.8. Again, annoying. We should be out to 4 decimal places. Almost every trig function we save the 4 decimal places. So I don't know who wrote this question. I would have a bone to pick with that person. -6.58, so that's -6. -0.66, excuse me. -8/7. Or excuse me, 8 divided by 7. That's -1.1. And then square root 113. Get it out of there. Divided by 8 is 1.328, which is 1.3. And square root 113 divided by 7. Oops, I didn't get outside the radicand. Oh, you doofus. What am I trying to do? Divide by 7. I know it's negative, but I can just write 1.518 rounds to 1.5, so it's -1.5. And then 7 divided by 8. That's negative. That's going to be -0.9. Okay? Now, the next problem is quite the same. So my suggestion is for you to hit pause right now and do that second problem on your own. Of course, I'm not going to sit here and wait. I'm going to keep making the next video because you're going to hit pause. So now we're told that sine of theta is equal to -2/7. So the sine of theta is equal to -2/7. And theta is in quadrant 3. So we have this going on. Zoop. We have the initial side. We have the terminal side in the third quadrant. Nothing's to scale, pretty much ever. There's my reference triangle, as I call it. My students know I've never read that anywhere. It could be this angle, or it could be its coterminal angle there, but let's make it easy. And this is theta. My reference angle is here. Oops, not theta, alpha typically. But we know that the sine of said angle is -2/7. So 2 is the, why did I write 7? 2 is the length of the y. And 7 is the hypotenuse, right? Because this is opposite over hypotenuse. And then the 7, the hypotenuse will never have a negative dimension. Never, 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 never. The hypotenuse will never have a negative direction. Technically, I have no idea whether the people who made up the system would have did this, but at least in polar coordinates, when I have rays extending from the origin or distances extending from the origin, then the negative distance would be in the opposite direction like this. So we're talking like vectors and polar coordinates and stuff, but it's not even applicable to this that what we're talking about. But it also makes sense that that negative sign is attributed to the 2 because I'm in the negative y direction, so we can just go from there. And I didn't, yeah, that's fine. And so I can now use the Pythagorean theorem, like I did in the previous problem, to find out what x is. So x squared plus y squared is equal to the length of the hypotenuse squared. And so x squared plus negative 2 squared is equal to h squared, which is 7. So I get x squared plus 4 equals 49, which is x squared equals 45, subtracting 4 from both sides. And so I get the length of this leg to be positive or negative square root 45. And of course, we could simplify that to be square root 9 times 5, which becomes 3 radical 5. But like I said, we don't care. We're going to just jam in the calculator and get a decimal. Or if we were allowed, because the guy wrote a better question, we would just put in square root 45 because it doesn't matter. Note that I'm being careful with this. When we take the square root of both sides, we are going to get the positive version and negative version of the number that satisfies that equation. And we have to use our brains. Oops, I covered all that up through the video. Hopefully you can catch up with that. Sorry. I'll hit pause and take a gander at all that stuff and catch your brain up and then unpause. So we have to be careful. We get both of those answers plus the square root of 45 and minus the square root of 45. And we have to use our brains to scrutinize those two answers and determine if either of the two of them is extraneous, meaning extra. And there is an extraneous answer. It's the positive square root 45. Why? Because this x is in the negative x direction, so this length of this is negative square root 45. The positive one is the extra one. Okay, so do the same thing that we did before. Sine of theta, cosine of theta, tangent of theta, cosecant of theta. Remember, they do it in a weird, and I would say a weird order, but I don't know why they chose this. I believe I choose it for a particular reason. I can't imagine why they chose it this way. But maybe somebody could tell me, and I would be corrected or enlightened, illuminated, and cotangent. But if you're doing it this way, because I just list the 3 and then I take the reciprocals and it's all lined up for me, I write it this way every single time. There's only one alternate way to write that I would write it. I would write sine, cosine, tangent, and if I was running out of room, I would write it this way. But notice how the reciprocals are lined up with each other horizontally. So, but again, someone might have a reason to list secant next, but I don't see it because my brain's stuck on my way. Again, there is no right. There are many right ways. There are also wrong ways. There's not one right way. Just saying. Okay, they gave a sine as negative 2/7. Cosine is going to be negative square root 45 over 7. Tangent is going to be opposite, negative 2 over negative square root 45, which of course is 2 over square root 45, because the two negatives, when divided, becomes positive. Cosecant is the reciprocal of sine, so we get negative 7/2. Secant is the reciprocal of cosine, so it's negative 7 over square root 45. Yeah, and then cotangent is the reciprocal of tangent, so I'm going to get square root 45 over 2. And then I have to put these in the calculator because of this particular problem. So here we go, negative 2/7. So I'm going to just go 2 divided by 7. Note that's negative. So that's going to be negative 0.3. So this is negative 0.3. I'm going to change colors because I can. Negative 0.3 is what I said, because 0.28 rounds to one decimal of 0.3. Why did I put squared there? Maybe I'm wrong. Hold on a second. Actually, I accidentally had a squared in there. Still 0.3. So somehow I didn't enter it all the way. Square root 45 over 7. So square root 45, get out of the radical, 7. So 0.95, which is, by the way, -1. And this is why the world would be angry at this person for having us round that, because this angle would have to be pi, or 180 degrees, to have a cosine of -1. And it's not, as 0.9583. So rounding into one decimal place is just wrong-headed. I have the capability, but I haven't had the gumption to edit those questions and fix them. But anyway. 2 over root 45. 2 divided by square root 45. 0.298, which is 0.3. And cosecant, which is -7 over 2. So that's 7 divided by 2. Don't forget the negative sign. So -3.5. And we're just kind of out of space, that's all. And then -7 over radical 45. So 7 divided by root 45. I get negative, because remember the negative, 1.0. Oh, it's so annoying. And root 45, get out of the radicand, divided by 2. And I get 3.4 positive. So that's 2 problems. Hopefully it's helpful.